Welcome all. So today we will continue with the random variables that we have started in the previous lecture. So we talked about the random variable and its types, which were the discrete random variables, the continuous random variables, and the mixed random variables. Now, apart from the random variables, there are the distributions. So we say the distributions are again divided into two particular types of distributions, that is discrete probability distribution and continuous probability distribution. So when we are talking about the random variables and their types, and when to the different types of the distributions we are assigning a probability, or we can say we are attributing a probability, then we are having the different probability distributions, and the distributions could be the discrete probability distribution and the continuous probability distribution. Then comes another thing which is called as the cumulative distribution function. As the name suggests, the cumulative distribution function is something where we can say that it is basically the summation of some distributions. Now we will start with the discrete probability distribution. So discrete distribution first. A random variable x is discrete if it takes countable many values. So that thing has been already defined, that if we'll be talking about a discrete distribution, it will be taking the values which can be counted, or we can say which are discrete in nature. Then the probability function or the probability mass function for this random variable is simply given as the probability of any of the values that has been assigned to some particular event. So we can say that the probability of x, which is basically a value from the line, or we can say the number line, is either 0, 1, or it can be anything between 0 and 1. And then when we talk about the probability function, we say that the area under the probability function is always equal to 1, or we can simply say that the cumulative value is equal to 1. That's if we are attributing the different values for the events from a sample space, we can say the summation of the probabilities of all the events is equal to 1. Now we'll be taking an example of a die. That is, if we are rolling a die, then we know that rolling a die means that we can have 6 different faces. The value of a face can be 1, it could be 2, it could be 3, 4, 5 or 6. So we can say the events that are possible from the experiment are that we can have a face with 1, a face with 2, 3, 4, 5 or 6. Now let us say that we are having a random variable x which can take on the values of the x as equal to x is equal to 1 is equal to 1, x is equal to 2 is equal to 2, 3, 4, 5 and 6. Then we know that the probability of occurrence of any of the events that we have defined from a random variable, that these are having the different values from 1 to 6. Now coming on the basic thing is the event, that is the face which is reflecting, whichever the face is reflecting is basically an event. Then we say the probability of occurrence of any event or the probability of occurrence of any value is equal to 1 by 6. Then if we'll be taking the summation of all the 6 values, so it will be 1 by 6 plus 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 1 by 6. So ultimately the probability of the entire experiment will be equal to 1. So the probability of mass function has been defined: probability if x is equal to 1, probability if x is equal to 2, probability if x is equal to 3, x is equal to 4, 5 and 6. So these values 1, 2, 3, 4, 5 and 6 are basically the values that have been attributed to the different events, and these values 1 by 6, 1 by 6 are suggesting the probability mass functions. Then we can talk about the continuous distribution. So we say a random variable x is continuous if there exists a function such that the following conditions are met. That is, this function is having a value greater or equal to 0, and if this particular function is integrated with the limits of minus infinity and infinity, it is equal to 1. And if the probability of a particular value, which is x, which is defined in between the two intervals a and b, is equal to the integration of the function over the two intervals or over the period from a to b. So the continuous distribution is defined as a function. So we can say if a random variable is continuous and there exists a function such that the following three conditions are met, then this particular function is a continuous distribution. Now we can have an example of uniform distribution, where in uniform distribution we say that if a particular function has the value equal to 1 over the range 0 to 1, and for the other values other than this particular range, which is in between 0 and 1, it's having equal to, its value is equal to 1, but the otherwise, that is if the value is greater than 1 or if the value is less than 0, the result will be equal to 0. So this will be a continuous distribution, and this particular distribution is a uniform distribution. So we could have a number of distributions, but this particular is a uniform distribution. Then we talk about the cumulative distribution function, or simply we can say CDF. Now the definition: if x is a random variable, discrete or continuous. So we don't say that cumulative distribution function is calculated for the discrete random variables only, or it's calculated for the continuous random variables, but it is for both discrete and continuous. Then if x is a random variable, then we say the probability of x less than equal to some particular value is called the cumulative distribution function of x, or simply the distribution function of x, and is denoted as f of x. So we calculate basically the probability of a random variable up to a particular value, which is from 0 to that particular value. So we can see here if x is discrete, we say the cumulative distribution function is equal to the summation of the probabilities over a period from 0 to j, and we can say that if x is continuous, we can say that it is basically the integration of the function from minus infinity to that particular value. So here we see an example again, that if we are taking the discrete random variable, suppose we are taking the same particular case where we are rolling a die and we are attributing the different values 1, 2, 3, 4, 5 and 6, and we know the probability of occurrence of any of the events is 1 by 6, 1 by 6, 1 by 6 and 1 by 6. Then the probability of this particular thing is that what is the probability of x less than equal to 1. So naturally we know that there is no such value which is less than 1. So from 0 to 1 we'll be having only this particular value, that is equal to 1 by 6. Then if we'll be taking on this particular example, that is, what is the probability of x less than equal to 2? So in this we include basically two probabilities. One is which is attributed to this particular value x is equal to 2, and this one is the probability attributed to the value of x is equal to 1. So these two will come under this particular probability such that the value is less than equal to 2. So naturally it will be the summation of 1 by 6 and 1 by 6. So that will be simply 2 by 6, or we can say 1 by 3. Then probability of x less than equal to 3 will be calculated as 1 by 6 plus 1 by 6 plus 1 by 6, and so on, such that in the end, when we'll be talking about the probability of x less than 6, it will sum up all the probabilities, because 1, 2, 3, 4 and 5 will naturally be less than 6. So it will end up with the summation of all the values. So it will be giving the value is equal to 1 at the end. Now these are the properties of CDF. That is, what is the cumulative distribution function for the value minus infinity. So naturally if we'll be having minus infinity, so it will be equal to 0, because we are summing up the values from minus infinity to infinity. So if we are summing up the values up to minus infinity, that means from minus infinity will be adding to minus infinity, naturally will be having the value equal to 0. Then CDF for infinity. So infinity is the extreme range on the right hand side of the number line. So naturally it will add up all the probabilities, so the result will be equal to 1. And this CDF is naturally a probability, so it can be seen as equal to or you can say that it is in the range of 0 and 1. And this CDF is an increasing function, so we say the distribution function, or this cumulative distribution function for any value x1 is less than x2 if x1 is simply less than x2. And we can see that the probability in the range can be calculated as the cumulative distribution function up to the upper limit minus the cumulative distribution function of the lower limit. So this marks the end of the lecture 5.